today's teleconferencing Gyan Darshan presentations for BIT students. Although I was supposed to talk about the projects for BIT second trimester, but today I will be talking about the basic fundamentals of computer networking. Once the project titles comes on the net and once you are prepared for doing this project, then we'll try to discuss the topics related to the projects. Now, meantime, I request all BIT second trimester students to go through a book written by V. Raja Raman on system analysis and design. This will help you to do a project. So it contains lots of information about how to do some analysis, how to do some designing for the project, and your main focus is on doing the analysis and design of the project rather than the coding part or programming part of the project. So you first read this book written by V. Raja Raman by Prentice Hall of India on system analysis and design. Once you are through with it, and meantime the project title will come, so we'll take up these topics related to how to do a project. Today I will be talking about in fact, today my first presentations on computer networking, and I will have a series of presentations on computer networking. And today we are starting with the basic fundamentals of computer networking. We'll talk about the OSI model, and you similarly try to work on the what I will call them TCP/IP model. So I will talk about so the basic issues, which the topics which we are going to discuss today is how we that just like a operating system, computer network is designed in terms of number of layers. You know that an operating system is also designed in terms of number of layers, and the kernel is the lowest layer of operating system. It is the kernel which interacts with the hardware part of it. Same way, all the complicated software is always designed in terms of number of layers and so on. Just like RDBMS also, or any database management system is also designed in terms of number of layers now. So first we'll talk about how the layers are organized, right? So, and the second one will be what are the interfaces. You know that all the layers are talking to others through certain interface. We'll talk about what is that interface and what are its services provided. So what are the services provided by sorry, by each interface and so on. Then we'll talk about what are the issues one has to consider when you design a particular layer. I will be not talking about a specific layer, but the generic issues I will try to raise, that whether you design, whether you are, which layer you are concerned with, you have to be concerned with certain basic issues. So we'll talk about design issues for various layers, starting from the physical layer to the applications layer, and then definitely we'll talk about function of all these layers. So this is all we have. These are 4 topics, and then I will again half an hour I will have a discussions, and then half an hour I will open for the discussions. And now I request all students who are sitting in the preview room, they will be talking to me at the number 361, and the students who are sitting outside at different TLC, they can make me call at 696-9345. Let me repeat once again that any questions related to today's topics only, and you have to confine to today's discussions only, you make a call from outside this building, 696-9345. So this is the basic telephone number you must note down, or you make a call after half an hour. Now let me talk about now how the layers are organized. So let's talk about, and I will be basically confine my discussion to only OSI model. I will be not talking about TCP/IP model at all. In fact, I had told you many times that if you want to learn network concepts, fundamentals of computer networking, then from learning point of view, from academic point of view, the understanding of the OSI layer is one of the most important activity you have to do. So basically, you know that in OSI we have a number of layers, and we have around 7 layers are there, and all these sub layers are, basically, they have been put into 3 subgroups. So let me show now. Here is the first subgroup is what I will call them network support layers or network support sub layers now. So basically I have organized all these 7 layers in terms of its functionality, that they are divided into 3 sub layers. First 3 lower layers are called network support layers now. So now what they do, basically they deal with the physical aspects of moving data from one device to another device. So this is right. For example, they deal with the physical addressing, they deal with the how to move the bits from one to another and so on. They move the data from bits or in terms of frame or in terms of the packets, but they don't, the one packet for these layers, the semantics or relationship among number of bits or number of frames or number of packets are not important. What I am talking about is that first 3 lower sub layers are divided are put into one subgroup because they deal with the lower layers, they deal with the lower functionalities, they deal with the movement of bits or the frames or the packets, and all these packets or frame go independently. There is these three layers does not put any meanings attached or any relationship between frames and the packets and so on. They deal with the physical level addressing. The second one, what I will call them, the user support layer. The upper three layers are called user support layers now. In fact, let me put one more point. The lower sub layers, physical layer, data link layer, and the network layer are always designed in terms of the hardware. All these functionalities are put into the hardware part. Whereas the user support layer, upper three layers, let's say presentations layer, session layer, and what I will call the applications layer, they are designed into terms of software. And the last one is what I will call them. This is one way to view the OSI model. Many books, they don't classify that way, but understanding the basic functionality, they can be classified into these three sub layers now. And of course, there is a transport layer, which is the fourth layer. Now, the job of the transport layer is to link these two subgroup, the lower subgroup and the upper subgroup, because sitting at layer number 4, to ensure that what the lower layers have transmitted is in a form that upper sublayer can use, so that there should be total compatibility between the lower layers functionality and the upper layers requirement and so on. And the another important functionality of the transport layer is to provide the quality, because the transport layer always assumes that the lower sub layers are not very reliable, because let's say the network layer, or let's say the subnet is being controlled, is not owned by a particular, it's basically is a public domain, so you don't have a much quality norms there. So it is the job of the transport layer to support the quality. Anyway, we'll talk about much more on the transport layer at a little later. Let's talk about, so basically now what are the issues which we have to be concerned. So basically first we explained you the number of sub layers now, number of sub layers, or basically we listed three sub layers or three subgroups for the all OSI model, or all the sub 7 layers of OSI model. Now if someone is concerned with designing a particular layer, what are the issues they are concerned with? So we'll talk about this one. Let's look at this slide now. So basically one has to be concerned with the addressing mechanism, right? So basically what should be the, how you have to do the addressing now, what should be each, how many bits of address, how many bits for the control, how many bits for the data, how many bits for other information should be put. So we'll talk about the addressing mechanism. One such issues which we have, like for example the IP addresses or TCP IP, they have 4 or 5 classes of addresses. One such class is called class D, is basically meant for the multicasting and so on. So basically one has to decide at different layer what are the basic addressing mechanism must be supported by the protocol now. So one such very important issue, any layer designer has to be concerned with it. At lower level addressing has to be dealt with. At a higher layer, we are talking about much more logical addressing. We have to be concerned with it. Like for example, then we have to be concerned with what are the rules have to be followed for data transmission, whether the line is used only for the simplex transmission, only one way channel, whether one has to transmit data in both ways or simultaneously, or let's say the basically what we call them half duplex. So basically one has to think of the simplex channel, or one has to think in terms of the half duplex channel, or in terms of the full duplex channel and so on. So this is another important issue, any layer designer has to be concerned with it. Then another important issue, because channel is not very reliable, the channel is always very noisy, so one has to be concerned with the error control mechanism now. So basically when we come with a data link layer, you talk about what we'll call them CRC mechanism. So CRC is one such mechanism which is being used with what we'll call them at the data link layer as the error control mechanism. Right now all these issues are generic. They are not very confined to a particular layer. It might happen certain issues one has to be concerned with number of layers now, but at least some of these issues have to be concerned at each layer. Then again the flow control is very important problem. So when you try to analyze various protocol, you have to basically understand in terms of these basic issues now, that which one supports better flow control, which one supports the better error control or the addressing mechanism and so on. But again, just let me go back to the addressing mechanism. You know that today when you work with the internet, you are basically using TCP/IP, and in TCP/IP is basically currently the 32-bit addressing mechanism they use. But sooner they are moving to 128, so you have much addressing range is much more higher there. And then another important issue at particular layer design. For example, we deal with flow control at both at the data link layer as well as the what I will call them at the transport layer, and they have a different mechanism there. So flow, because the reason being is that at data link layer you deal with the data transmission between two immediate nodes, whereas the network layer and the transport layer you are talking about end to end. So the again flow control problems comes at everywhere, and one has to think from a different perspective. So flow control is basically that the receiver and the sender must have to fully whatever sender is sending, receiver must be able to recognize them and able to receive them. So the sender should not be very fast, so that the receiver will not able to receive all the data again. So flow control problem. So in data link layer we'll deal with various flow control mechanism. One such mechanism is what we will call them go back in. Second is called selective repeat. So these two are again flow control mechanism. At the transport layer we'll deal with flow control mechanism, and we'll introduce a different type of technique for dealing with flow control mechanism at transport layer and and that is called sliding window protocol with certain credit value. And then finally another issue which we don't deal with at each layer, but of course it is confined to particular layer, what we call them fragmentations and reassembly. Because so basically in the wide area network the packet goes from one router to another router, and it might happen, and you know that the when we work with when we try to study the data link layer protocol, we deal with many such protocols, and you will see that all the protocols are not alike. They are different in terms of the packet size, the packet format. One is very fast, another is very slow. So let's say talk about the if packet size is very large from one network sender side, and the router is not able to receive all the packet in totality, so it has to break in terms of number of other fragments. So when we deal with fragmentation, means that I have to number each fragment, so that if they have to be reassembled at the destination side, they all should be reassembled such a way that the semantics of those fragments must be recognized properly. So these are the basic issues one has to be concerned with designing the layer. In fact, these are the issues one has to be concerned when you try to study one protocol or another protocol and so on. So when we examine the TCP/IP protocol, what exactly I am looking at it? I have to see the addressing mechanism. I have to see how the TCP/IP handles the flow control, and many other issues which we have not listed here. They are basically connection, or what we call them, what type of services they provide, or what sometimes what we call them how they handle the congestions and so on. So many other issues, but these are the most important issues. All the protocols must deal with it. And then basically, if you try to understand, we are talking about interfaces now. So before coming to the functionalities, let's try to understand the interfaces. Each lower layer provides certain services to the higher layer. Now each lower layer provides certain services to the higher layer at certain interface. Just see this slide down here is at certain point, a certain port number. For example, your mouse is connected to your computer with serial port. So basically all the services provided to the mouse is available through this port number. Or for example, that all the web server with FTP services, they provide you at particular port number. HTTP services are provided at particular port number, or the telnet is provided at particular port number, and so on. So basically port number is basically certain addresses. Like for example, your telephone number, again you have a telephone connection at your house that's connected with certain certain points. So that is the basically address through which you get your telephone number and call and so on. So same logic has been extended to in designing the layers also, that each sub lower provides certain services to the higher layer, and all the services are provided through this port. and so on. So basically, if you try to understand at the upper layer level, then it means that if FTP, if my machine is a part of the internet, if they have to provide certain services to anybody else who wants to connect to my machine, let's say FTP service or a telnet service, so I must provide a particular port number. Certain port numbers are standard. No other system is using those ports, let's say port number 21 or let's say port number 80. When you write HTTP, when you surf your internet, when you surf your web page, by default it is a port number 80. Same way, each lower layer provider the services to higher layer at a particular port number. Right. So basically, and each layer provides certain services to you. I am just simply giving you an overview rather than going into detail. So what are the issues have to be concerned at lower layer? You must understand connection oriented service, the connection less service, and one example of connection oriented service is basically what I will call them telephone belongs to this type of services. So or all type of reliable services which I want to provide to certain we call them we have to use a connection oriented type of feature now. Connection is not all the time you require a connection oriented service. For example, simply I want to send email to thousands of people, or let's say I want to flash their stock codes, or I want to flash certain message. It's not required for anybody to be well connected that time, or if they miss certain information particular time, that also is not very much important. So again, while designing the layers, again one has to be concerned with it that what type of services we have to provide now. Like for example, TCP supports the connection oriented service, whereas IP supports you datagram service, what we call connectionless service. Each services have its drawbacks and advantages. So depending upon the situation, you have to pick up and program accordingly. And all these services are characterized by quality of service. You read this point as O now, quality of service now. And we'll talk about, when we come to the transport layer, we'll talk about in detail what exactly we mean by the quality of service. Like all the reliability has to be within, let's say for example, let's say I'm talking about, take example of little bit, let's say give one example to understand the whole basic concept that suppose that I want to send my data in a much more reliable way. So there must be, this means I am talking about quality of my file transfer and so on. It must be safe and so many parameters are there. Many, just like in software engineering, you read many matrices or many parameters to see whether the software has been designed meet all the criteria or not. Same way, the services provided by each layer are measured. They are basically benchmarked, and all this benchmarking is basically called quality of services now. So depending upon what type of service you want, accordingly quality of service has to be defined. But this is basically confined only at the transport layer onwards. We don't deal with quality of service at lower layer. And let's talk about now each layer now. So let me talk about very quickly now that what are the functionality of each of these layers. We start from the bottom layer, we call the physical layer now. And let me list very quickly the one such service, or let's say one important functionality of a physical layer is called multiplexing. So you have to understand various techniques for multiplexing now. And you know, two basic standard techniques for multiplexing is what we call them FDM, frequency division multiplexing, or time division multiplexing. But again, they are called a static type of thing because the channel is booked in advance for these two. But they are most simplest techniques, and we use all the time these type of things. Like for example, radio broadcast or the television broadcast, or you see some advertisement in between when the serial is going on. All are example of the FDM and TDM. Right, so basically multiplexing is one such technique now. But multiplexing is not a domain of only or functionality of the physical layer. We deal with multiplexing even at the transport layer also. But so basically same channel can be utilized by many. But there our perception is different. There we have a different view about multiplexing now. But at a lower layer, of course, but basic objective is same. When we say multiplexing, we always mean utilization of the channel. For example, I have given you this example number of times here from this studio, that for example at your home, if you have a cable TV and your bandwidth of your cable TV comes around 500 megahertz, and to have a color transmission of your television you require maximum 6 to 8 megahertz, and in between of course you write certain band or certain gap so that signal should not be overlapped. So you just can calculate that at the same time I can have 500 divided by 8, so many channels concurrently, simultaneously one can do it. Otherwise, you have 500 megahertz and only one channel is being supported by this system. It means remaining channels are not utilized and so on. So basically, this is example of a multiplexing. And again, at a data link layer, at physical layer itself, you deal with the whether the transmission is going in both ways or single way or at a time only one directions and so on. Again, these issues have to be dealt with at the physical layer and so on. Topology, again, the whether line topology, you understand, we have discussed the topology there, but here topology might be that whether the line is, whether two devices are directly connected or whether two devices are connected through certain intermediate nodes and so on, whether line must be available for these two devices all the time or line might be shared in between by somebody else and so on. So all are basically part of the physical layer. The another important thing here at the physical layer is what we will call them signal now. Just see at signal now. Now signal is again that the all informations can be, I will talk about the signal little bit later, because the informations can be transmitted only in form of a signal now. Now anything is information, voice is information, your data is information, any picture is information, but I cannot send picture just like a picture, it has to be translated into form of a signal now. So we'll talk about signal at a later stage. The another important issue which we discuss at the physical layer is called the encoding technique. What are the basic patterns of encoding now? For example, when you type something from your keyboard, you type let's say capital A or a small a, it creates the set of bit patterns, ones and zeros. It's based on certain convention, either you are using EBCDIC or whether you are using the ASCII system. Same way, when I'm sending the signal out through some channel outside, it has to be encoded what type of bit patterns will be represented for a particular signal. So that is another important issue you have to understand. And of course, there is a medium now. Medium, I could be a wireless medium, it could be wired media. I can use a cable, I can use a coaxial cable, I can use a baseband, I can use a broadband, I can use a twisted pair, I can use a fiber optics, or I can use any type of a spectrum. There's a wireless media, I can use them for transmissions of my signal now. And picking of each of these medium is based on certain characteristics, whether you are using again depending upon like for example another important parameter of picking of particular type of media is basically bandwidth. Again, the bandwidth is based on certain characteristics of this one and so on. So again, you have to understand the characteristics of the twisted pair, characteristics of the what I will call them baseband coaxial cable or the broadband coaxial cable, fiber optics, and of course the characteristics of the wireless media. So all these issues are part of the physical layer. Means studying all these things will be part of your physical layer understanding. And then we'll talk about the signal now. You know that basically signal is again very much important, and signal information can be in the form of data, voice, picture. Already I told you. To be transmitted, information must be transmitted into electromagnetic signal. That you have to understand now. Now the signal, again you have to understand it could be analog signal, it could be a digital signal. And what is the difference between analog signals and digital signal? The analog signals can have any value in the range, whereas a digital signal have a very discrete value or a limited number of value, 0 or 1 and so on. So this is the difference between analog signal and digital signal. We deal with all these signals. Both type of signals are basically used in transmissions. Now a signal, sometimes called signal, is periodic if it consists of continuously repeating patterns. Same sinusoidal waves are repeating. This is called what we call them periodic signals. Aperiodic signals, where we don't have a fixed patterns of repetitions. A periodic signal can be decomposed. Again, we'll not go into that mathematics. It can be decomposed into state of sine waves. All signals are basically have a this type of sine wave type of characteristics. And can be, so it could be a complex signals. All complex signals can be broken into simpler sine wave signals. Now each sine wave or each signal can be characterized by its amplitude, what we call the instantaneous height of the wave. It can be characterized by the frequency, it can be characterized by the phase. So we have given you definitions here. So this is basically, and now what is important, you have to understand the bandwidth of a signal now. Now bandwidth of a signal is again the range of the frequency of the signal occupies now. You must understand the bandwidth of this one. You can't change the bandwidth, but having the same bandwidth, I can increase my data rate by different encoding techniques. The bandwidth is determined. How do you determine the bandwidth? It's determined by finding the difference between the highest and lower frequency components and so on. So any channel which carries the voice, they might have 4 kHz. So this might be limited. The lower frequency range is 0 or the highest is 4 kHz. So the actual bandwidth is 4 kHz. So that way we try to calculate the bandwidth, electrical characteristics. Now how we do the encoding technique, that is again we'll spend some time, not today, but here of course you must understand that the different techniques are there. Means how the bit patterns will be used now. I mean how the signal will carry simple 1 or 0 or might be containing many bits and so on. Or how we are transmitting. So basically whether I am transmitting digital signal, then how the transformation will take place. So I have a 4 type of what I will call them information, analog informations and the digital information, and I have 2 types of signals, analog signals and digital signal. So it's basically 4 combination I am getting. The digital data is being represented by digital signals, analog data is being represented by digital signals, right, and basically the digital to analog or analog to analog. So basically there are various techniques are there, and they all are used in the computers for data transmission or for transmission of the data. Let me give you one small example now. What exactly we mean by digital to digital? Basically, let's say for example, if data is being passed from computer to the printer, right? So basically what happens is that you don't need to convert them into analog directly. It basically same digital data goes to the printer and you try to print your data. So basically here one combination is what I will call them digital to digital. In that case we are simply using these 3 type of techniques. We will not go into those details. I have given one small example what exactly we understand by digital to digital. One example I gave you, that if I want to take the printout, but actually data is coming from your system, from your CPU or from your memory, it is basically in digital form. So same digital data is being transmitted in form of a digital signal, and the technique is basically used unipolar, polar and bipolar. The analog, this is very interesting now, which you have to understand, is basically that if I have to translate the analog data into what I will call them some digital signals, or basically I want to transmit some to what I will call them digital signals. I want to transmit analog data into digital signal. For example, in what type of situation I come across this type of situation? For example, let's say for example I am recording my sound on my CD now. So basically I am creating basically audio wave now. Now this audio wave will put into the digital format, digital signal, by using a PAM. PAM means the pulse amplitude modulation. So this is the basically used in the CD. So when we have creating a multimedia CD, when we have a audio and a video, they all are basically in analog form. So if I have to do the recording on digital on the CD, which has to be played by the computer, again we use a PAM. Basically means what happens is the basically all your what I will call them, the signal, analog signal is basically sine wave now. So they go through this process, analog to digital conversion has got number of processes now. So first what will do is they take the amplitude value of your signal and then they try to quantize them, and finally they put them into the quantization, means that giving the integral value of your signal now, and then finally they convert them into ones and zeros. So the PAM is basically the first process, and then we have a PCM and so on. So basic technique for analog to digital goes through number of process. One for the taking the amplitude value, then quantizing them, giving integer value to it, and finally putting them into ones and zero and converting them into digital signals. So these are the basic techniques I use for the encoding. And then we have a data link layer. I just will try to quickly finish the whole functionality and take up your questions now. that the responsible for delivering of data units. So basically, the what it does now. Let's look at this slide. Responsible for delivery data units from one station to the next without any error. So again, error control is being used at a data link layer. It accepts a data unit from the third layer, that is network layer, and adds meaningful bits to the beginning and the end, the header, trailer, and actual data, and contains addresses and other control information. So basically, one important job of data link layer functionality is what I will call them grouping. Is basically what will do the grouping of this one, and what we'll call them framing. So let's try to list all the important functionalities of this one. First, I will just look at this slide now. So we have, first is what I will call them framing, putting all the bits into some logical meaning. The node to node delivery, that is very much important, and that is where you try to understand how they are different. You see, basically when at a data link layer we are talking about data transmit, we are concerned with two intermediate nodes. We are not concerned with end to end. Right, the addressing mechanism, again I told you that when your frame contains, the format of the frame contains the addressing mechanism, how many bits you are putting them for the what I will call them for the destinations machine. The access control, many machines might be using same channel passes through. So all your network, basically when you work with local area network, you are basically concerned with a data link layer. In fact, you are concerned with a specific layer, sub layer of data link layer, which I have not listed it, that is called MAC layer. Now, same channel passes through all the machines now. So all are trying to grab the resources now. So the system has to decide now what should be the policies now, that which one will be able to access a machine at or channel at a particular time. That is what I am talking about, the access control. Again, flow control mechanism. In flow control, I have already explained you that two basic techniques are basically used. Two techniques basically used here. At the data link layer, we'll talk about go back in and selective repeat. Even a stop and wait. A stop and wait is another important flow control technique at a data link layer. What happens is, but the stop and wait is not very what I will call them very efficient type of protocol, because you send a packet and unless you get the acknowledgement, you are not sending the next packet now. But just assume that when you are sending your data through the satellite and getting data from the satellite, it will take lots of time. The propagation delay is much more longer than the normal local area network. So channel utilization is very, very poor now. That is why the flow control, that is why we have evolved different type of techniques called go back in and selective repeat. So these are the two flow control mechanisms. Error handling is another important issue which we discussed at the data link layer, and the CRC one such mechanism. And then there is a synchronization. The sender and the receiver must understand that when these first they must be totally synchronized. They must understand this is the end of the first, this is the end of the second, and so on. So all are part of the data link layer. Then we have a network layer. Now let me read. Responsible for source to destinations delivery of packet across multiple network links or lines, whereas data link layer oversees. This is difference between network layer and the data link layer. Look at this slide now here is, and try to read this once again. Whereas data link layer oversees node to node delivery, the network layer ensures that each packet gets from its to the final destination using optimal route. That is very much important. So first is talking about end to end. Again, we are coming back to here, but again one has to find the optimal route for it. And there are various schemes are there for finding out the optimal route, and we'll read all this in the second year or third year. That here basically what you have there is that you have a flooding is one such mechanism, and then the Distrage algorithm is another such a mechanism used for finding out the optimal route, and so on. So basically one is important is network, the source to destination delivery, the logical addressing. At lower layer you deal with the very physical addressing, but here talk about logical addressing, routing and switching. This is another important functionality. Most important functionality is this one. Again, the address transformations from the logical to physical backward, and what again we'll talk about the multiplexing. Another important functionality of the network layer also, that because the channel has to be, the same channel will be used by number of nodes, or the single one will be carrying over the data. So again, but most important is this one. When you try to understand network layer, you try to concentrate on what I will call them the routing, even congestion control, another important issue we discuss at the network layer itself, and we'll discuss number of algorithms here. Transport layer is again which is a bridge between the lower sublayers and higher sublayers, and most important job is the basically quality control now. But let me just look at this slide once again. Responsible for source to destinations delivery of the entire message. That is important, you have to understand. Whereas network layer oversees end-to-end delivery of individual packets, it does not recognize any relationship between those packets. So again, when just you see now, saw that the network layer also delivers the packets, the frame, the data link layer also delivers the frame, but they don't recognize the meanings between these two, from how these two frames are connected. They don't have any semantic sense. But whereas the transport layer deals with end-to-end protocol, it deals with one message now. So fragmentations, reassembly issues all come as a part of the transport layer. Again, multiplexing is another important. What exactly? Now you can ask them how you are looking at multiplexing at transport layer. So basically, let's say for example, I give one such example. Multiplexing means suppose that I have a lease line now, and I am paying fixed amount to Department of Telecommunication because I have a 2 Mbps lease line. But not all the time I am using my lease line. Although I am paying fixed amount, does not matter how much data I have uploaded or how much transactions I am doing through this one, but how much traffic high I am supporting here. But I am paying the fixed amount. So now I can do that. The time which I am not utilizing them, I can ask someone else that you utilize this time and pay some amount to me. So again, this is also a multiplexing. So we deal with this type of issues at the transport layer. Again, end-to-end message delivery, already discussed. The port addressing, I told that each one has so basically when data is coming from the top to the bottom, again it gives you the actual address here, what port address is assigned by this one. But most important issues which we study at the transport layer is multiplexing issues, end-to-end message delivery, the segmentations and the reassembly, and again quality of services. For example, I want fast delivery of my packet. Again, these issues will have to be programmed, have to be examined only by the transport layer, what type of user you are, for example. So all this programming, when you do TCP/IP programming, you basically sitting at the transport layer and network layer. And finally, the session layer is the network, and then we talk about session layer now. Now look at this slide now. Session layer is the network dialog control. It establishes, maintains, and synchronizes the interaction between communicating devices. It also ensures that each session closes appropriately rather than shutting down abruptly and leaving the user hanging. What exactly? So let's if you try to see, basically it deals with 4 or 5 issues now: session management, synchronizations, dialog control, graceful close. What exactly? Let me give one example to understand that what is the role of the sessions layer. For example, I am transferring 2 MB file, and moment I have transferred the 500 bytes of the file, there is a communications failure, or there is congestions, or there is a router failure on the way. Now next time I am resuming the retransmission, whether it will start from 500 bytes onwards, or it has to start from the 500. So there must be some synchronizations point or the control point where the things stopped, and from there I will be transmitting the remaining data. So this is all part of the my sessions layer. And finally, the presentations layer. The presentations layer ensures that the interoperability among communicating device. It makes it possible to find computers to communicate even if their internal representation of data differ. It provides the necessary translations of different control codes, character sets, graphic characters, and so on. For example, what happens something like this: if you are working with a different browser, some browsers are basically designed under Unix and they have a different file format. Some are designed Windows NT, some are Sun Solaris. So the job of the transition layer to deal with all the software incompatibility. You as a programmer, you are not basically concerned. So the job of the presentation layer, and something this type of characteristics you don't find into the TCP/IP model. They simply put only into 4 or 5 layers. So we have to understand. So network designing is not only do the addressing and the routing and the connection control managing, but also have to do with software incompatibility also. So the precisely deals with the translation. Some software is designed with EBC DIC system, some with the ASCII system, some under Unix, some under window NT. So basically do retranslation. Then encryption of this data. Again the security issues are also discussed at the here itself. And finally we have a compression issue. Now again data has to be compressed now. In fact, this is the advantage of the digital type of transmissions, that you can compress your data. You can provide security of your data, whereas if you are dealing with the analog type of data, you can't provide all these mechanisms. And finally, you have the applications layer. It provides the user interfaces and supports all the FTP, telnet, everything is basically supported at the applications layer, right? And the important is this one, the remote login, the file transmission, network virtual terminal, the mail services, directory service. So all are basically part of the applications layer. With this, I will just simply close, and I will wait for some more questions coming in, and then I will try to start with. Okay, now so I am waiting for some of your questions. So if you have any questions, please ask now. You can, these students who are sitting in this studio, they can make call at 361, and students sitting at different TLC, they can make a call 696-9345.
Hello?
Yes.
What are the points one should consider during logical design process of a network?
Sorry, just repeat questions once again.
What are the points one should consider during logical design process of a network?
Logical design process
of a network.
What exactly you mean by logical design of process?
Sir, that I don't know, sir.
So basically, see, all the time what we have discussed so far is basically logical design related issues, right? We are not basically going at the hardware part of it. All the issues which we have listed here are the functionality which we listed for all the layers are basically logical design issues. For example, if I am basically, if you simply minus the physical layer now, all the issues which we listed now at the data link layer, network layer, presentation session, all are basically related to the logical design. So basically what exactly I am concerned with from the logical design point of view means all are flow control mechanism. For example, flow control mechanism is again logical design issue. Means I have to design the system such a way that even if this receiver has a less memory and or even less this one not very as fast as the sender, but receiver must be able to receive all the data precisely. So again, so I have to deal with the routing, how to find how to send packet optimally. That again is the logical design issues now. To provide software incompatibility, again this is logical design issue. So all the issues which we have listed right from the data link layer onwards to this one, all are logical design issues. But more precisely, which we listed earlier is multiplexing at the transport layer is logical design issues. The fragmentations and reassembly again is a logical design issues, because how many fragments you want to break in your packet, so that reassembly must be very much easier. So all are basically logical design issues. Yes, please. So basically, see, I have just let me just please think over your questions now. I am just simply what.
Hello.
Yes, please.
Sir, what is the difference between multitasking and multiplexing?
Multiplexing is something different. Multiplexing is basically again there might be some similarity between the two, but other two different concepts are there. Multiplexing is basically utilization of the channel. For example, I gave you one example of a multiplexing. That for example, you have a cable TV at home, and the bandwidth of this cable TV comes around 500 megahertz now. Now this 500 megahertz has to be optimized, right? And the color transmission, suppose that I want to have a Sony TV at receptions, then it simply requires maximum 8 megahertz now, if in color transmission I am talking about. But the bandwidth of your channel is 500 megahertz. So you understand this, that if only one transmission is going on at a time, then again the bandwidth is not utilized or channel wastage is there now. This is called multiplexing now. But multicasting is that if I am sending, that three similar terms are there, what we call them broadcasting, sometimes say the unicasting, but let's try to restrict to only these two, broadcasting and multicasting now. Multicasting is basically if I am sending the message to some group, right? For example, it's basically used for when I am doing the video conferencing for particular corporate organizations now. So I am basically using multicasting because this message is not going to everyone, but going to particular group of the society and so on. So if I am sending my data to particular group, I am simply calling them multicasting. If I am sending to all, this is a broadcasting now, right? In both, all are basically leading to optimization of the channel, you can say otherwise, but otherwise there is clear cut difference between the two. Yes, please. See, right now we have again today we have listed the OSI models now. We have simply talked about 3-4 issues we identified today, that if somebody had to design the layers, what are the issues one has to be concerned with it. We didn't talk about a particular one. In fact, I listed all the functionalities, so now you can easily map them, that if I have to design, logical design of course, if I have to do with a data link layer, now what are the issues one has to be concerned with it, how you have to do the framing, how you have to do the basically error control mechanism, how you have to do the flow control mechanism.
Sir.
Yes.
So how do we differentiate between multiplexings being done at 3 different layers, the physical layer, data link and the transport layer?
So basically the multiplexing, yes, this is in fact good questions. Now the question is that how do you differentiate between a multiplexing at the physical layer and the multiplexing, what I will call them at the transport layer, for example. The example which I have given you just right about the multiplexing is the basically of the physical layer now, directly thinking in terms of the hardware point of view, that same bandwidth, same coaxial cable can be used for multiple channel at the same time. But from the transport layer point of view, it's entirely different now. There I am utilizing my channel in different way, but the purpose is same. Whether you do the multiplexing at the transport layer or at the physical layer, the objective is same, that you have to optimize the channel now. Now the difference between the two is that I gave you another example. Let me give you repeat this example which I have explained you while discussing the transport layer. That let's say I have a lease line facility now. I have a 2 Mbps lease line facility. I am talking about how to do multiplexing at the transport layer. I have 2 Mbps lease line service now. Now suppose that, and I am paying the fixed amount to Department of Telecommunication, but I am not utilizing my channel all the time. So I can hire someone, or I can use somebody else requirement, and I can, okay, that you can use my 2 Mbps channel for downloading or uplinking whatever we want for let's say between 1 to let's say 5. So again here is also called multiplexing now. So again this is what I gave you example for the transport layer now. Yes. So when you examine now, so these are the issues we have to understand, and the physical layer is very much important. Although it's not a logical design, but it's basically physical design. But physical, to understand how really whole the network really work, you have to understand all these basic issues now. Because to understand computer networking fundamental, you have to understand the data communications issues now. So what we described as a part of my physical layer discussions, all are very much important. In fact, you must understand that how we do the encoding, right? And the one example I gave you, that you have to understand that, for example, how we convert the analog data into the digital signals, that you must understand how we do multiplexing. In fact, I listed only 2 multiplexing, but there are many other multiplexing techniques are there, which we discussed, let's say for example, and so on.
Hello?
Yes?
What is subnet boundary in OSI model layer?
Sorry?
What is subnet boundary in OSI model layer? And why does network layer controls it?
Sorry, what is subnet boundary?
Yes, sir. Subnet boundary in OSI model.
See, basically subnet is basically a term, see, basically used in the, if I have understood your questions correctly, that the this basic concept is basically used in the what I will call them wide area network. in wide area network, basically we call these certain set of each subnet. For example, I have a one local area network, right? It could be one subnet. Then so this my whole boundary is belong to one LAN, right? So we use certain type of addressing mechanism for the local area network, but when it goes to outside this subnet, then the addressing mechanism has to be different because it's passing through certain routers and so on. Right? It can be, this concept can be extended to in multicasting also. They always try to see if I'm trying to link your multicasting and with this one, it fits very well. That when I do the multicasting, again I use a subnet boundary because I am not trying to address the information to everyone. I am basically targeting my information to particular subnet. Right? So this is basically this subnet boundary is might be. Again, like for example, from multicasting point of view, it could be one small LAN area, could be one subnet, another small area, another area could be another subnet, and so on. So this is basically, both are connected through routers and some other network devices. This is basically, I understand, like if I try to relate your questions very well. So we use this type of subnet.
Hello.
Yes.
Hello, sir. Is there any rule for a OSI model that which protocol is used in which layer?
Definitely, there is certain standards now. There is standards now. In fact, I didn't talk about, but we have a standards now. For example, let's say for example in IEEE, each layer you have certain standards now. And this is the advantage of learning the OSI model. TCP/IP does not talk about such things very precisely. Simply, TCP/IP has validated them. For example, you take example, if your mouse is connected to your computer now, your mouse is connected to again there is certain protocol between, and the protocol is called RS-232C. Your computer is connected to the port printer. Again, it has a certain protocol called Centronics, or what we call them. They are connected with parallel ports. So there are certain rules are there. So in physical layer itself, your computer talk to modem. Again, there is certain set of standards are there. So there are large set of standard at each layer now, depending upon what a function is basically being used now. So we have a V21 again, and then many such protocols are there, X.21, X.22, and so on. And at data link layer, we have certain standards. For all the local area network, we have certain standards. For example, it start with IEEE 802.12, 2, 3, 4, 5, 6 till goes to 11. I think 802.11 for the wireless networks. Right? Again, we have SDLC protocol and so on. This is again, so all are standards for the data link layer. If you go upward, the network layer, you have a IP one such a standard, but many other such protocols are there at the network layer. You go further at transport layer, you have a TCP one such a standard, UDP another such a standard, and all are basically used. And again, you have if you see the transport layer at the applications layer, there are series of standards are there. What you have. HTTP, FTP, Telnet, and so on. So all are basically, they have certain standards are there, and all devices work based on certain protocols. Yes, please. So basically, you think of your questions. Let me just summarize quickly. Basically, what we have discussed today is that I have given you. In fact, there are many number of. Yes, please.
Sir.
Yes.
Sir, can I ask somewhat out of the range of this topic?
Yes, please.
Sir, what's snooping? Snooping.
Looping.
Snooping. I've just seen this word. Nothing is even about its definition, or nothing. Not even a single line definition is there.
No, I think we want to.
Snooping is also a word, sir.
I think it is not with security issues. I think, are you concerned with that one?
Sir, it's somewhat after the spoofing, but there are two different words, snooping and spoofing. We have read about spoofing, but we don't know about the snooping. Okay,
so I will little bit, but I think right now I will not able to tell you precisely, but I will tell you the basically pointers is this one, that somehow it must be related with the security issues. So anyway, I will just write down this question. I will back to you, but it must be linked with some type of security breach and so on. It might be linked with that one. So anyway, so basically what we have discussed today is we have given you the various listing, various functionality of all the sub layers, and today, but main focus today I gave you about the physical layer. Physical layer is the same as the data communications. So apart from the standards which you are going to learn at the
Hello,
data.
Sir.
Yes, please.
What is the significance of X.21 interface at physical layer?
No, they basically, see, I told you, I will give you basic examples of this. See, basically there is a protocol called X.25. There is a protocol called X.25, and X.25 basically comprises three layers. It's basically a standard for 3 layers. X.21 is basically a standard for the physical layer, and so on. So basically they basically deal with all types of devices. They are basically used at the physical, what I will call them, at the physical layer. So this is standard, just like I gave you example now. It somehow it validates those standards also. For example, I gave you like the RS-232C. It somehow validates the RS-232C also, right? So like for example, RS-232 is a protocol. It basically use how you work with a serial port, right? So again, X.25 also validates, it's basically how the serial port or how the devices working at the serial port work and so on. So basically those things are. So X is a part of X.25, and X.25 is called the network layer protocol. You can put them at the IP level, but it not like, you know.
Hello, sir.
Yes, please.
What actually that interface is, sir? Please tell in detail.
See, the interface is basically what? For example, I gave you logical meaning of interface. For example, a lower sublayer provides you certain services to the higher layer at certain port number. So the port is basically interface between two sublayers. For example, when you connect to, I am giving you logical as well as physical meaning now. So let's say coming from the logical meaning side, like for example, your server, your client, suppose I want to do some browsing from a particular Yahoo server now. Now, if you are doing browsing, means you are doing some HTTP service now, or that system Yahoo is supporting you certain browsing facility at certain port number. So the port is basically interface between you as a client and the server. So means all the services provided by HTTP services, any such type of facility provided by the Yahoo server is available to you through HTTP protocol at port number 80. So that is also interface, but very higher layer now, right? At a logical, at the very, very lower level, that is called at a physical layer.
Hello?
Yes, please.
Yeah, sir, I have a question. Yeah, what is the difference between modulation rate and the data rate? Is there an example where both are same?
No, data rate is something different. See, the data rate is something different. I mean, question could have been little bit. Modulation is one such technique for sending the data along the communications channel now. Like for example, you know that modulation is one such technique now, like amplitude modulation is one such technique. The frequency modulation is another such technique. These techniques are used for encoding of the data, right? So that is the another way, that way you try to understand. But the data rate is something different. Data rate is basically decided, but those can, if you have a better encoding technique, then you can achieve a better data rate. That way you can try to relate these two issues now. That if you have better, remember I have discussed here many times that if you have a higher bandwidth, you can achieve the higher data rate. But if I have a same bandwidth, I am not increasing my bandwidth. Let's say I have a 500 megahertz. This is my channel capacity now. Means my bandwidth is fixed now. But by different modulations techniques or different encoding techniques, I can increase my channel capacity. Now by using different techniques, so modulation is one such technique, and so on. I have listed number of techniques. So modulation is one such technique for sending the signals across the channel. You remember we have discussed various other. You just remember the very famous law, which of course we didn't discuss with the BIT second trimester. That is the Nyquist law. If you remember the Nyquist law, then we have the another one side, that is the left side, we have a channel capacity, and then here we have a 2W, like twice bandwidth, and then multiplied by log to 2 power m. So this m is basically show you the what we'll call them the voltage level now. So if you have a number of voltage level, then more bits can be carried over. So that's something can come with the modulations and so on. So modulation is one such technique for encoding. You can say that way, to simplify the meaning. Yes, please. So if you don't have question coming, so basically you try to, now I will just try to the word this you must read, try to understand what is encoding. Two things are very important to understand if you want to understand the relationship between the bandwidth, channel capacity, and the data rate and so on. You have to understand three things, what are the basic relationship are there, and two famous law are there. One is to establish the relationship. One is called the Nyquist law and second is called Shannon's law. And the difference between the Shannon's law and Nyquist law is the Nyquist laws always assumes that your channel is not a noisy now, right? They never consider this one as a factor now. But whereas the Shannon's law is always considering that your channel is always noisy. So when you try to calculate the channel capacity, always you try to consider channel signal to noise ratio S divided by N now. Right? So these are very much important, that how the speed is basically getting achieved. Whether I can change my bandwidth of a channel. No, you can't change the bandwidth of a channel, right? Because bandwidth is based on certain electrical characteristic, how thick your twisted pair is, and so on. So you have to, accordingly, you have to pick up a particular type of channel now. But once you have picked up the channel, you can't increase the channel capacity. Sorry, you can't increase or decrease your channel bandwidth. But given that bandwidth, by different encoding techniques, you can increase your channel capacity. And you see, remember, keep on increasing the value of M, your channel capacity will be given. But there is a limit that you can increase the value of M by any modulations techniques and so on. So that relationship must be, you must understand. In fact, this is the basic law in the computer network. In the physical layer, we discuss with only this one, then we start. This is another very important issue you have to understand. The another equally important at the physical layer is which you have to understand, that how, let's say, yes please.
What is encoding techniques?
Encoding techniques we have given you. Like for example, let's say for example, when we type something from the keyboard now, when we type something from keyboard, there is a basically the patterns of ones and zero is being generated now. So there are two conventions, EBCDIC and ASCII system. So these two are encoding techniques. How your character will be represented in terms of bits patterns now. This is encoding technique. Normally we use EBCDIC from the computer point of view, but from the network point of view, by encoding techniques means that how many bits a signal is being carried over. Whether you have a digital signal or whether we have encoding signal, how you are trying to represent your digital signal, how you are representing your analog signals, and so on. These are called encoding techniques from network point of view. But if you have not understood from the network point of view, you try to understand normally how do you work with computer. In computers also you have a encoding techniques. So basically you use a ASCII system, you use a EBCDI system. So like say for example A. Now A has a certain what we'll call them hexadecimal notations now. That is basically what we'll call them, that is called encoding technique. Anyway, this we are coming to an end, and the next lecture again will be on computer networking, and I request you to read a book by V. Rajaraman on system analysis and design. This will help you to do the project, and once the project comes on the web, we'll explain you how to do a project. Meantime, I will be discussing about computer network. We'll discuss with the basic topics as well as the topic assigned for next time discussion. It might be IEEE standards we'll be talking about next time. Thank you very much.